Okay, fall 2010, number 11. We have y equals x squared plus x all over x minus 1. And at first we're asked to find the x and y-intercepts. And so when x is 0, it'll turn out that y is also 0. So it goes through the origin. Now when y is 0, of course we'll get, in return again that x is 0. But let's find out what happens. We have x squared plus x all over x minus 1 equals to 0. Well, that just means that x squared plus x is equal to 0. Which we can factor as x times the quantity of x plus 1 equals 0. So that we get either x is 0 again for the origin, or we get x is negative 1. And so that's our other point of intercept. We intersect the x-axis at both the origin and at negative 1. That's part A. Part B, find the vertical asymptote. Vertical asymptote is where the denominator is equal to 0. And so that happens at x equals 1. Okay, part C, find the slant asymptote. Slant asymptote occurs when the degree of the denominator is 1 less than the degree of the numerator. So x minus 1 is 1 less than x squared plus x. And so yes, we'll have a slant asymptote. We could either long divide x minus 1 into x squared plus x, or we could use synthetic division. Either one works fine. Let's use long division. We'd be forced to use long division if the denominator was quadratic or higher. You multiply by x. You have an x and you need an x squared, so you multiply by x. You distribute that over to the x minus 1 to get x squared minus x. You subtract the entire thing, and you end up with 2x. Bring down the constant term of 0. And you have an x, you need a 2x, so you multiply by 2. Distribute that across, we get 2x minus 2. Subtract the whole thing to give us a remainder of 2. And so what you're basically saying is that this function, y, which was x squared plus x all over x minus 1, can be rewritten or renamed as x plus 2, and then the remainder goes underneath the divisor. 2 over, the remainder goes above the divisor, 2 over x minus 1. And so what happens as x goes to infinity, then the 2 over x minus 1 goes to 0. And we'll have the line, I'm sorry, not equals 0, but it goes to 0. So we'll have the line x plus 2. So y equals x plus 2 is your slant asymptote. Okay, so we have y equals x plus 2 is the slant asymptote. X equals 1 is the vertical asymptote. And these intercepts for parts A, B, and C. Part D, find the intervals of increase and decrease. Alright, so we need to find where the derivative is equal to 0. we have two choices. We could use this new version of the function x plus 2 times 2x x plus 2 plus 2 over x minus 1, or we can go back to the original version and use the quotient rule. Both ways should work. We'll do the first thing that comes to your mind, which would be to go back to the original and use the quotient rule, where we take and square the denominator, bring the denominator up to the numerator, multiply it by the derivative of the numerator, which is 2x plus 1. And then we're going to have a minus, where we'd have the numerator, x squared plus x, and that's going to be multiplied by the derivative of the denominator, which is just 1. And so that's going to simplify to be 2x squared plus x minus 2x, foiling out the first term in the numerator, minus 1. That's all the FOIL of the first term. Then we apply the minus to the second term, minus x squared and minus an x. And all of this is divided by the quantity x minus 1 squared. Great. So how many x squares do we have? Looks like we have 1x squared. How many x's do we have? Negative 2 of them. And what's our constant term? Negative 1. It looks promising. It looks like it might factor. In fact, it looks like it might factor to be x minus 1 quantity squared. But like our denominator looks like. But no, that's a minus sign in front of that 1 there. And so the terms are different. So it doesn't factor. And so this is your derivative. You try to set it equal to 0. And it will then cause you to take the numerator and set it equal to 0. So where does x squared minus 2x minus 1 equals 0 doesn't factor. We've already established that. So we have to use the quadratic formula, which says that x is the opposite of b plus or minus the square root of b squared minus 4a. Now c is a negative 1. So that gives you a positive 8 all over 2a. And so we get 2 plus or minus the square root of 8 all over 2. And we recognize 8 underneath the square root as 2 roots of 2. And so we can cancel these 2's and have that x is 1 plus or minus the square root of 2. So 1 plus the square root of 2, 1 minus the square root of 2. Those are your two x values that make your derivative 0. 1 minus the square root of 2 is smaller. 1 plus the square root of 2, the bigger one. And your derivative, your denominator is always positive. So that doesn't determine the sign of your derivative. It must be from the numerator. The numerator is a quadratic that opens up. So it has the following sign distribution. A parabola that opens up and it crosses the x-axis at those 2 points will have the following sign distribution. It'll be positive dipping below and going negative, and then going back to being positive afterwards. You can use test values if you want, but you will see that it is the following sign. That is to say that that represents the sign distribution on your derivative, which in turn can answer the increasing and decreasing question. At the same time, we can quickly get the local max, local min question as well, where 1 minus root 2 leads to a local max, 1 plus root 2 leads to a local min. We have the levels of increase and decrease, and then we can take it and put it all together to sketch the graph. And on this exam, I would ask just parts of it, and so we'll say that we are we are increasing here, decreasing here, increasing here, and then if they want the actual max and min value, local max and local min, we have to take these and plug them back into the original function. So I won't do that now, and you wouldn't have to worry about sketching the graph, but you should be able to put the whole thing together. In the interest of the length of this video, I need to stop, but hopefully that's enough to help you through it. Yeah.